Hello, this is Ramasu, and welcome to my presentation on questions 6 to 10 from the 2012 BGCSE Science Double Award Paper 1. Question 6 reads, the diagram shows a nut held by a spanner with points labeled W, X, Y, and Z on it. At which point would you have to apply the greatest force to loosen the nut? The answer there is W, which is in this case is A. Right. This question is to do with the principle of moment, and a moment is given by force times distance. Right. So to get the moment you need to loosen this nut, you either have to increase your force or your distance. So if your distance is if your distance from the pivot being the center of the nut or the bolt, this is your pivot there. The bolt is your pivot, right? So if your distance from the pivot is large, then you need to apply a smaller force. But if your distance from the pivot is small, then you need to apply a larger force. Okay. Question 7 says the diagram below shows a cooling curve of a certain liquid. So which temperature value is the freezing point of the liquid? Okay, so we can see that the temperature is decreasing all the way from there up to here, right? And for this period, the temperature of the liquid remains constant. At this point here, there's a change in phase. A change in phase. Right. So the liquid is transitioning from being a liquid to being a solid. Right. So at this point here, you have a mixture of liquid plus solid. Right. So then the temperature remains constant during this phase or during this change in phase. Right. So the freezing point is where the temperature is constant. So then this is 30 degrees Celsius. Right. Part 8 or question 8 says the diagram shows a helmet of mass 0.7 kilograms falling with a constant speed from a very high building. Right. What is the value of force F? They tell us that the helmet is falling with a constant speed. See that constant speed? Constant speed. This means that the object has a zero acceleration. Now, if you remember the formula, F is equal to ma, which is force, is equal to mass times acceleration. This force here, this force is a resultant force. It's a resultant force. Now, a resultant force is simply the difference between forces. For example, if you have, say, a box here, you have a box, and then you have one force pulling in this direction. So let's say this is 10 newtons, right? And then you have another force pulling in the opposite direction, and this is 5 newtons. So the resultant force would be the difference. Okay, let's call this F1 and F2. The resultant force would be the difference between F1 and F2, right? The resultant force would be the difference between force 1 and force 2. So then this would be 10 newtons minus 5 newtons, right, giving you 5 newtons. So because this force is bigger, then the object will move in the direction of F1, right? So then, because our force here is not 0, this means that acceleration is also not 0. If we have a resultant force, then acceleration is not 0. Acceleration is non-zero if we have a resultant force, right? Now they are telling us here that the object is falling with a constant speed, which means that our acceleration is 0. And if our acceleration is 0, if we put 0 into this equation, because the mass is 0.7 grams or 0.7 kilograms times 0, because 0 is our acceleration, it means that our force is 0. This means that our resultant force is 0, right? Our resultant force is 0. So then if our force here is 0, this means that weight is equal to F, right? Because the difference between weight, we can call weight F1 and we call F2. So then it means the difference, see, resultant force would be the difference between F1, right, and minus F2, and our F1 here is weight, and our F2 would be F. So it means that the difference between weight and F is 0. So this means that weight minus F is 0, right? So which would then mean that weight is equal to F, right? Because if you take away F from weight, you get your answer as 0. So then the question is, what is the weight of the helmet? Well, weight is given as m times g, where m is mass and g is the gravitational pull, right? So we have 0.7 times g is 10. So then our answer here is 7.0 newtons. So our weight is equal to 7.0 newtons, and because F is equal to weight, then F is also equal to 7.0 newtons. Question 9 says, the diagram shows a heating element placed in a glass jar. Air is completely removed from the glass jar, right? So if air, okay, let's continue with the question before. By which method or methods does heat reach the walls of the jar when the heater is switched on? Okay, so because air is completely removed. They tell us here that air is completely removed from the glass jar. This means that there will not be heat transfer by convection, right? Because convection is a type of heat transfer that occurs in fluids, and fluids are liquids and gases, right? Fluids are liquids and gases. So because there's absolutely no air in here, then we cannot have convection. So all the answers that have convection in them, this one and this one, we can cancel them out. So then we are only left with B and C. But the main method of heat transfer here is going to be radiation. The main method of heat transfer will be radiation. Heat will be radiated from the heater to the walls of the glass jar. The same thing happens with the sun and the earth, right? If this is earth, and obviously this is the sun, right? So so light and heat, well, let's say heat reaches the earth from the sun by radiation, because we know that in outer space there's absolutely no air, right? There's no air in outer space, no air or no atmosphere. So the only way that heat from the sun can reach the earth is by radiation, right? So if you imagine this as the sun and the walls of the glass jar as the earth, the most important method of heat transfer here would be radiation, right? So our answer will be B, conduction and radiation. Conduction because this heat element is in contact with this base here. So heat will be conducted through the base to the glass jar, right? Part 10 says, which of the following electromagnetic waves has the shortest wavelength? As we can see from this diagram here, that gamma rays have the shortest wavelength, right? So the wavelengths are shortened as you move from radio waves to gamma rays. So our answer here will be gamma radiation. Okay, so this is the end of this video. My name is Ramasu. You can find me on Facebook, or you can follow my Facebook page, BGCSE tutorial videos. Thank you for watching, and see you in the next video.